they have a color shift. And so my argument was basically that if you think about light as particles, and that they have this constant speed thing, that all you're basically doing is changing the number of particles that are produced. Okay. And that and that's the change. That's the color shift, is because they are particles, and there's the period is basically defined. The period of the frequency is defined by the production of a particle, a photon, and that explains it pretty well, because there's no other real explanation. You can't, if you really can't add speed to something, and you can't take speed away. So frequency really isn't about speed; it's about actual frequency of particles. But whatever, I don't want to get lost in the whole physics thing. But what was my point there? Yeah, so I still say the speed of light is the constant, and what can change is how many of the particles, or how much energy is absorbed out of, what light is traveling through. If obviously there's going to be impacts, and those impacts are going to absorb all or nothing, in my opinion. I don't buy the argument that light has all or nothing. Anything other than all or nothing, that photons have anything other than all or nothing interactions, that you can't just subtly interact with a photon. You either interact with it terminally or not at all.
Pretty much right? And the quantization,
you either take all of its energy or you take none of it.
Yeah, and that's kind of quantum theory, is that light will act that way, and that's one reason light might just shoot by something or get absorbed. And when it is absorbed, you can tell by the color of light that was absorbed, what was absorbing it, because certain things only absorb light of certain colors and emit them too. So, but it's not true about the frequency is not like the frequency of the photon emissions. A single photon actually changes wavelength depending on your speed relative to it, because like you say, it can't change speed. So you can't change its propagation speed. So what changes instead is its wavelength. If you were moving away from the source of it, it'll seem redder, and it's just like, it's the Doppler shift. A car comes shooting by, it's like high-pitched, and then as it passes you, it's low-pitched. And that happens to each and every photon. And then, depending on the speed that it has, depending on the wavelength it has, rather, relative to what it strikes, it'll either be absorbed in an all or nothing way, right? Which is a really important thing. It's one of the main tricks they use to get knowledge in astronomy, is that you have this absorptive, these quanta of absorption.
Well, I know, but see, that's where the thing kind of fails, though, because how would, instead of looking at it as the receiving body moving, okay, but that is another angle to it. So if you're running away from the light, and you're running away close to the speed of, you're running away as fast as you can, and the light's coming at you, and you're running and running and running, and so, by this logic, you're taking some of the speed off the light because you're running in the same direction as the light. So now, relative to your position, the light is moving slower. All right, that's sort of that argument then. And what I'm saying is how would that work in the inverse when a body is producing a shift? Like, say the observer is neutral, and a body is moving away as it's producing light. Okay, that's where I don't understand how that shift can be imposed on a particle. How could the photon know when it's being emitted that it's a blue or it's a red?
Well,
when it's being emitted that it's a...
Well, okay, Einstein's explanation of that is why he was saying space is warping, because if you just think of it as space warping, so our relative velocities makes the size of space kind of spongy and change. And so even though the math works out that the velocity is always the same, the consistency of the space wasn't the same, so that the end result is this, it doesn't slow down, but it looks red. And it's exactly the same with the emitter, because, the emitter or absorber, you're always at rest with yourself. So you shine, you burn some copper and it makes that blue flame of copper. And if somebody's moving away at you at a really high speed, that looks red. And if they're moving towards you, then it could get compressed and be an X-ray. And, it sounds weird, but it makes sense because it's just like if you're going towards a car, if you're going 1,000 miles an hour, that thing's like a bullet. And if you're going 2 miles an hour, it's just like, I don't know, a pillow or something. So it's the same with the light. It's just that it plays this weird game where the speed is always the same, but the energy, the amount of energy in that photon changes. And so if you're going towards it, your relative motion, not towards it, towards its emitter. That's the thing. I keep saying towards the photon. It's towards the emitter.
But see, that's what I'm saying, though. By my frequency argument, that is also covered, because the faster you're moving towards it, you'd be increasing the frequency, and if you're running away from it, you'd be lengthening the frequency. So, I mean, it's the same argument. And then I guess I would also argue that how do we even know what one photon is? So let's say that, because that's the quanta, right? I mean, that's what we've defined as the one. Okay, that's mass of, I mean, they say 0, but let's say that's mass of 1. I mean, that's the first smallest 1 bit. So how do we know that when we're even measuring a photon or calling one thing a photon, that it's not actually 2 photons, a beginning and an end? Okay, like, that the photon, that what we're calling a photon and saying it has a frequency could actually be 2 photons, okay, that are tied together by some sort of what we call the speed of light. They're tied together by a bond that establishes a distance that is reducible to what we perceive as a speed of light. That is the clock speed of the universe, is the distance between those 2 photons. I'm just saying, but when we measure it, we'd have no way of fucking knowing, because we have no way of knowing. We have nothing to detect it with. We have no fucking way to even describe the appearance or shape. I mean, a photon could be a galaxy for all we know. I mean, all we can do is say this is the smallest thing we can measure. If I said that right. I mean, we're still going to measure it without knowing what it is, how it's structured. So it could be much more complicated than our model.
Well, it is, but that just makes you start to be phantasmagorical, right? Because we only know the fact that we have like rods and cones in our eyes that will make a little electrical spark if a red photon hits it. So it can be detected in that sense, but you're right, it could be a whole galaxy hitting it, and it just makes that little tiny event happen, and so that's all we notice. And there's a lot of this kind of stuff going on in physics. That's the whole point of this dark matter. There's 96% of everything around us would be this dark matter, and we're right in it right now, and we've only studied this little tiny bit, and and it is the size of a galaxy, and we're only seeing a little teeny tiny non-existent bit of it. But I mean, I'm fine with that. Yes, it's always going to be something else. We just have this model, but
Yeah, no, I'm just saying, but in the model, but the frequency thing to me makes sense. So that's why I was focusing on frequency, because to me, frequency is.
You're right on that.
To me, is where the change in the energy is frequency, and frequency basically reduces to volume. So I'm just saying that now you can understand the energy more in the hydrodynamic kind of sense, because when you start talking about volume, it gets understandable. So it's the volume of light that defines its intensity, is how I'm arguing it. And it's so frequency establishes volume, and that establishes force.
Guess you can decide which is the fundamental, but they are absolutely linked. You can relate the link to the volume when you're traveling towards the photon and you're compressing its frequency as you speed up towards it. It's compressing its frequency. Einstein's idea of space warping is all about the fact, well, you're actually compressing the space. So in some sense, its frequency is the same, but it has less space in it. And since we see the space as less, we see the frequency as more, because that's just how the mathematics works. And as far as that goes, I mean, I'm endorsing that. That's exactly what relativity says. These are the main points of relativity, and why we think a lot of the things we think. That's why